All right, question number 11 says a thin copper rod, 6 millimeters or meters in length, is heated at its midpoint and the ends are held at a constant temperature of 0. When the temperature reaches equilibrium, the temperature profile is given by Tx equals 60x times 6 minus x, where 0 to 6 is going to be our constraint. That's going to be the position along the rod. The heat flux at a point in the rod is equal to negative K times T prime X. Okay, that's the derivative, where K is a constant. If the heat flux is positive at a point, heat moves in the positive direction at that point. If the heat flux is negative, heat moves in the negative direction. So we're going to know when, with K equals 1, what is the heat flux? At X equals 1, at X equals 5, and then for what values of X is the heat flux negative or positive, and we're going to explain the statement that heat flows out of the rods at the ends. All right, so we are given equation of the temperature, Tx 60 times 6 minus x. So this is going to be a parabola. I'm going to go ahead and distribute this out. 60x. I'm missing my x here. 60x. 6 minus x. Okay. That's going to give me 360x minus 60x squared. All right. I'm going to also find T prime. It's going to give me 360 minus 120x. And we are going to need the heat flux, which is going to be negative K times this T prime. Okay. So first we want to know with K equals 1, what is the heat flux at X equals 1 and 5. All right, so we'll plug in a negative 1. Basically, we'll do a negative, and then we'll do T prime of 1. T prime of 5. So plugging in a 1, we'll just do 360 minus 120. When we subtract 120 from 360, that gives us 240, but it'll be a negative. So this will be a negative 240 when you plug that in. When we plug in 5, so 5 times 120, that will give us 480, 600, and then that will give us a positive 240, or negative 240. Negative times a negative will give us a positive 240. Okay. So heat flux at 1 is going to be a negative 240. And then when we're at 5, we get a positive 240. All right, so now it wants to know for what values of X is the heat flux negative. So like if you were to imagine this is a parabola. This thing is going up and down, and it's looking at the rate of change when we hit that midpoint 0. So we have a negative part and a positive part, or positive and negative. When our slope is positive, we're going to get negative outputs. When our slope is negative, that negative times a negative is going to give us a positive output. So basically, if we set this equal to 0, we can find the restraints. And it looks like about 3, halfway between 0 and 6. But if we set that equal to 0, we'll get a 120 x equals 360, and divide by 120, and we get x equals 3. So 3 is going to be that midpoint. So from 0 to 3, or 0, 1, and 2, when x is less than 3, we're going to get positive values. Here, positive will end up being times a negative value here and become negative. When we do 4, 5, and 6, those are going to be on the other side of this maximum. These will give us negative inputs here, and then so a negative times a negative will give us a positive. So it looks like from what values of x is the heat flux negative, up 0 to 3. And then we want to know what values of x is the heat flux positive. That's going to be when it's greater than 3. So 3 to 6. So not including 3, but on the other side of 3. Yeah, that's the right one. All right, and finally, explain the statement that heat flows out of the rod at its end. Okay, so at its end, it's going to be on the very tip. So T1, 0, so more on the negative side. So when it's negative, it's going toward the negative side. So we're going to set this statement when the heat flux is negative, which is 1 in T1, we get negative 40, which is less than 0. So that means it's past the end of the rod. And then when we do T5, kind of like what we just did in the beginning, is equal to 240, which is greater than 0. So it's going to the right. So that's what these are saying. Greater than 0 is going to the right. That's going to the left. That one, not really sure what those two are saying. And this one does not have the right sign. It says T1 is 240, which it was negative, and it says T5 is negative, which it was positive. So best answer choice here would be A. Sorry, I need to do check.